Hi, this is Richard C. I'm a math tutor here at Wyzant, answering a question submitted by a student. This is a classic Algebra 2 style question involving composite functions. We have R, which is the rate at which crickets are chirping. It's a function of temperature, but temperature in turn is a function of time. So let's start with R of f of 6, and we're going to interpret this in the same way that we would evaluate it. F of 6 is the temperature when T is 6, which would be midnight, okay, because it's 6 hours beyond 6 p.m. So the time is midnight, and R would be the rate at which the crickets are chirping at midnight, which I'm just going to abbreviate a little bit. Chirping rate at midnight. So you always start with the inside first. So F of 6 is the temperature at midnight, and then R is the rate of chirping at midnight. And so let's do the math. So this is R. We replace F of 6 with 0.3 times 6 squared, which is 36, minus 5.4 times 6 plus 71.8. And so, according to my calculator, that's 50.2. So all I did was replace T, because it's F of T. T is replaced by 6. And that's how I got this number. And that comes out to be 50.2. Now R of 50.2 is going to be, it's coming from up here, it's going to be 4 times 50.2 minus 160. And that I have to do on the calculator. 50.2 times 4 minus 160 is 40.8. And this would be chirps per minute, CH over minutes. Chirps per minute at midnight. Okay, so that's pretty straightforward. Now the general case, R of F of T, that's just going to be the chirping rate at T hours since 6 p.m. Because instead of giving us an actual time, which is here, we have to use the expression for T, which is hours since 6 p.m. But it's definitely a chirping rate because R is on the outside. Okay, so this is evaluated much the same way. it's going to be r of 0.3 t squared minus 5.4 t plus 71.8. Now we're going to apply the R formula here. You multiply this by 4 and subtract 160, so it's going to be 4 times this very same thing, 0.3 t squared minus 5.4 t plus 71.8. So you multiply it by 4, and then you subtract 160. And you would put this on your calculator because you want to now set it equal to, so I'll just change colors, set it equal to 60. And when I do that on my calculator, I get 4, t equals 4. So what that tells me is the chirping rate is equal to 60 at, well, it'll be 4 hours, so it'll be 10 p.m. Okay, so that's what that means. So we've set the chirping rate equal to 60 and found that the time is 4, and that means 10 p.m. So it's a lot of words here, but it illustrates the utility or usefulness of composite functions. It's whenever you have a function of a function that these composites come in handy, and you can see that they can come in handy in the real world. Also, you'll see composites again when you're in pre-calculus and again when you're in calculus, so you'll have plenty of time to study these. But I think the word problems are particularly challenging, and you just have to kind of break it down in pieces. Okay, so that's it for today. I'll see you guys next time. Bye-bye.